So today we'll go with some of the image registration process. So if we take the image over time, then if the sample moves, then we need to know that how much sample moved. We have to correct the common area. We have to find the common area, the image movement. So we have to know that is there any movement of the image? If there is a movement, how much it moved, and we have to correct the image. Say for example, in our case, this is the reference image, and we'll compare with this image with another image. Say we just moved some portion of the image here and there, so we just reverse, we just bring back, say, this portion to start of the image. Say this is the actually this portion of the image is here, and we move upside down. That means some portion of the image, top portion of the image of this one, we brought it here. So we are calling, say, this is our current image, and we'll compare with our current image with the reference image. This is our reference image. Now if you do some analysis using cross correlation, we'll be able to see what is the change. So if you see that figure number 3, this figure, we can find that what is the area of common image. So this is the area where the reference image and current image both are common. So we can calculate the common area. So one thing we need to know is over time, as there will be a lot of images, and we need to figure out the common area of all the images. So to do that, one way is to move all the images in one corner. So this image, we can move this image this way, that corner with respect to this corner, all the images. So whatever we will find, so this is, say, for volume 1. So this is for actually, say, if reference image is for volume 1, if reference image is for volume 1, then this is, say, for example, volume 2, and we can do the same thing for volume 3 or volume 4. Like, we can stack all the images in the one corner, something like this. So then finally we can do some other analysis. So let's see how we can do these things in the MATLAB. So in MATLAB, say we are loading some image here, and we are calling this as a reference image, and we are shifting the current image. We are generating same image, just we are circular shifting the image, and see how things run. So let's do it. So up to this, say this was our current image, this was the shifted image, we shifted. We can see here that, so this is the cross correlation part of the image, and the maximum, absolute maximum value will tell us some story. So we are finding the maximum value inside the whole image, and we are trying to see where is the row and column location of the C max here, maximum value of this. If you look at row and here, so row value is 342 and column value is 21. So let's see where are they. This is our shifted image. If we look at here, this corner, let's zoom in. It will be easy to do that here. If we zoom in only this portion, then it will be easy to track this. So now if I zoom out, we'll see that the corner position, like where X and Y axis are matching, is this location. So now we know the column and row position. This is detected by that. So we can calculate that the dy, the movement along the x-axis and movement along the y-axis. Let's see. So if we look at the shifted x and shifted y, here is shifted x, shifted align and shifted align. So this is 20, this is 50. If we look at, we move the same amount, 20 and 50. So this can definitely detect the image movement, like how much image moved and what is the current location. Let's try for new value. Say for example we put, say here plus 40. Say for example here is we put say minus 10. Let's see, can it detect or not. Let's run and see. It's loading, and you see the location of column and row is 62 and 41. Let's see, or is 62 and 41. So it always pick the corner. That's the advantage here. So here we can see that this corner is so it detected this corner. So it will always detect this. This corner. So 62 here in the column value. If we look at column 62 and 41, column 62 and 41. Here we can see from the image 2 that it's detecting the 62 and 41 position. Now if we go further, how much it shift? If we look at the shift align equal to minus 10 and shift frame is 40. So it can clearly detect the actual value. Now rest part of the code is to detect the two condition, that how much it moved. Here this condition, it will detect this condition, and it will also bring back whole image to one corner. So this part of the code is for align and also, and this is the shifted comparison image, and this is the other image. So let's go move forward and see how things goes on. So you can see that it can clearly detect how much it moved or it moved, and so these are the images. We can zoom in bit and we can see that it can detect this is the final movement in one direction. So if we compare this one and that image with this image, we can see that it made 0. So here is a value will be 0 where it moved. Here this portion is moved, so it can make it 0, and finally it moved all the data to one corner. So in this way actually you can track and you can register the image and move according to your will.